to introduce a keynote speaker. This is Dr. Ayorkor Korsah. She currently serves as the head of Department of Computer Science and Information Systems at Ashesi University in Ghana, where she teaches courses in robotics, AI, programming, data structures, and algorithms. Her current scholarly interests include exploring the application of technology to development-related problems and strengthening computing education, particularly in the African context. She's also the co-founder of the African Robotics Network, which she co-founded with Professor Ken Goldberg in 2012. Dr. Korsah holds bachelor's and master's degrees in computer science and engineering from Dartmouth College in the US and a PhD in robotics from Carnegie Mellon University in the United States. Please join me in welcoming Dr. Ayorkor for the keynote address. So I will stop sharing my screen here. Okay. All right, Dr. Ayorkor, are you all set? Looks like you're muted. Do you need help getting unmuted? Let's see. Just give me one moment. Let's see if we can help with that. Could you try again to unmute yourself? Okay, so.
Got it now. Great. Thank you so much.
Yes, awesome.
And can you see my slides?
Yes, your slides are visible. Your video is on. Audio is great.
Thank you so much for the warm welcome, and thank you so much for organizing this event. I think this is really a landmark publication and a landmark event, and it's really a pleasure and a great honor to be invited to share some thoughts at an event that I see as rekindling a vision that started almost a decade and a half ago. As Kenny mentioned, the African Robotics Network was founded in 2012 with the aim to promote communication and collaborations that would enhance robotics-related education, research, and industry on the continent. And one of the flagship programs at the time was the Ultra Affordable Robot Challenge, which invited robot designs from people across the world, thinking about how to create an affordable robotics kit for education in Africa. As of the last data I kept record of was 2015, where we had about 400 individuals, 59 institutions in 56 countries as members or, on the African Robotics Network mailing list. And at the time, the robotics landscape in Africa was a little bit sparse. This is not necessarily a completely accurate representation, but only a couple of countries, particularly Egypt and South Africa, really stood out as having a very strong robotics ecosystem with graduate programs and significant industry. Countries like Kenya had some undergraduate programs related to mechatronics and some robotics-related industry. And in West Africa, we tended to have, isolated courses in different universities, a number of competitions and challenges. And of course, several other countries also had competitions, challenges, and activity at the, say, high school and primary level. But now things have, and at the time, there were, I think, 3 countries that had chapters of the IEEE Robotics and Automation Society. Things have really evolved quite a bit now. As it's highlighted in the State of Robotics in Africa report, almost all countries in Africa have robotics competitions and challenges or participate in them. At least a dozen, by my estimation, at least a dozen countries have degree programs in robotics and mechatronics, and there are 8 countries that have chapters of the IEEE Robotics and Automation Society. So the landscape has changed quite a bit, and as is highlighted in the reports being launched today, The ecosystem consists of four main aspects: industry, talent and workforce, research and innovation, and policy and regulation. And coming from a university point of view, it's important to realize that universities play a very important role in at least two of these four, pillars of the ecosystem of robotics in Africa. And so I'm hoping that in the next few minutes, I can just share some perspectives of how a university can play its part in developing this ecosystem. And in particular, a lot of my work is driven by the philosophy that a key stimulus to development in Africa is the empowerment of young Africans to become problem solvers and innovators. That is to become creators rather than simply consumers of technological solutions. And this, of course, includes robotics, this includes artificial intelligence. And I think this is something that those of us focusing on education in Africa really have to pay attention to in terms of what our goal really is. When we think about how universities can build capacity for the robotics ecosystem in Africa, a few sort of key avenues come to mind. The bread and butter of most universities is sort of the undergraduate programs that they offer. And so that is, of course, an important avenue for building capacity for the workforce, for any kind of development that's going to take place in Africa. We have, in a discipline like robotics and related disciplines, the importance of postgraduate programs and getting into the space of innovation and actually charting the future of the technology is important. And that's where, the postgraduate programs that exist and are being developed are important. And then several universities, although their main focus is higher education, also look at how they can develop the pipeline earlier in the educational process. So they look at how they can support things happening at the high school level or even at the primary school level. And then, of course, we have research, which is really, that creation of knowledge and is a very important and essential aspect of higher education. And so in the time I have, I just want to share a few examples from the experience of Ashesi University, where I work. It's a private, not-for-profit university in Ghana. So this is, definitely from the West African context. And I'll preface it by saying that the primary mission of Ashesi is to train a new generation of ethical and entrepreneurial leaders in Africa, to cultivate within our students the critical thinking skills, the concern for others, and the courage it will take to transform the continent. So whatever we do is really driven by this mission. And so even when we're talking about, robotics and engineering, and very sort of technical things, this is really underpinning our choices and what we do. With respect to undergraduate programs, establishment in 2002 had major.
It looks like we are losing Dr. Ayorkor there. Hopefully she can rejoin. Yes, okay. Dr. Ayorkor, it looks like your audio is not coming through at the moment. Let me see if I can help with that on this end. Okay, hello, Dr. Ayorkor. Can you?
Yes, I'm back. Thank you so
Yes.
much. Sorry
All
about
right,
that.
no worries.
Yeah, the realities of West Africa. So, um, one thing it's it doesn't allow me to unmute myself, so if or share my video. So if that happens again, you will need to unmute me. Like you
All right.
just did.
Yes.
Thank you so
Yeah.
much. And I hope it won't happen again, but anything is possible.
Absolutely.
So
Thank you.
yes, so with respect to the undergraduate programs, apart from what students learn in classes and what they do as part of capstone projects, what they do in clubs, what they do in collaboration with faculty, or even in personal projects, form part of all that capacity building. The very first robotics course at Ashesi was actually offered 20 years ago in 2006. And at the time, Ashesi didn't have engineering programs. It only had computer science and business. And the goal really was to expand students' notion of what was possible with computing and to give them that exposure to working with sensors and all the wonderful sort of educational advantages that working in robotics gives. And at the time, one of the participants talked about how, I used to be afraid, but I have more confidence now. And this really shows the power of robotics as an educational tool. And, at the time, there was really no robotics industry in Ghana. And so, some of the discussions we had with the students were, why do you think we should be studying this? Is this really relevant? And I think it was captured, very well by one of the participants who, a couple of years late after the course, who said, I think it'll be good for students, and in time, real world applications for the African continent will emerge from this exposure. And I think we're definitely seeing this as captured in the State of Robotics in Africa report. And I think it's something that we should keep in mind because we're not educating for today, we're educating for the future. And so this really should inspire this notion of, okay, what will the future look like should really inspire everything we do in universities in Africa. So, building on that 2006 experience over the years, Ashesi has gradually introduced various courses related to robotics and intelligent systems, so that students really have the opportunity to learn a lot in this space, even though they may be majoring in computer science. We're pretty traditional in the majors we offer, so we don't have, for example, a robotics major specifically, but students have the opportunity to really learn a lot in this space, and it's culminated in the launch of a mechatronics major a few years ago. A key thing to make this effective is a project-based learning approach. So just to give an example, in the key undergrad robotics course, the first two-thirds of the course give a very broad theoretical and practical introduction to robotics, covering everything. The usual things you want to learn about: sensing, vision, actuation, control, navigation, planning. We do a fire hose. And then the last third gives an opportunity for students to go in depth in a particular area of interest based on an open-ended project. And this sort of model of having education driven by real-world projects has worked really well for us. So just to give an example of a class project that a team did in this course, they developed, a multi-robot search and rescue system where they had a drone which would take an image of an area, come up with a map which a ground robot could then plan in order to execute some task. And so this kind of project really gave them the ability to integrate the various things that they had learned in the class, albeit using educational platforms like the EV3 robotics kits that we used at the time. For students who are really interested in robotics, they tend to then carry this forward to capstone projects. So, for example, Benedict Quarte, as part of for his capstone, designed what he was aiming to be an affordable autonomous vehicle development platform, with the argument that one of the reasons why we're not doing self-driving research in Africa is that we can't afford, self-driving vehicles. And so, could he develop a miniature version of a self-driving vehicle that used the same principles? So still using computer vision, still using machine learning to learn a control system, right? But on a scale that is affordable for researchers in Africa. Benedict then, went on to enroll in a in his PhD at Brown University, where he's doing amazing work in robotics now. Other projects include things that involve more fabrication. So, for example, here's a system that SORA developed to sort cowpeas to reduce the tedium that women who sell cowpeas go through in sorting them. We've had a more recent project related to automated fermenting and sorting of cocoa beans. Cocoa is a very important agricultural crop in Ghana. So we see that with the right sort of exposure in terms of the technical content, as well as opportunities to really think about the local context, students can really, as was said by one of those very early students, really figure out what the applications in the local context can be, and we build a vision for the future. In terms of students earlier in the pipeline, in 2012, Ashesi started running a program for high school students. In 2014, we changed the name to the Ashesi Innovation Experience, which is a 2-week residential program that brings high school students from all over Ghana, but also some other African countries and further afield to Ashesi for a 2-week intensive program that, in the spirit of Ashesi's sort of liberal arts educational philosophy, engages them first in concepts around leadership and design thinking, and then based on their interests, they get to focus on either robotics, engineering, entrepreneurship, or the creative arts. And the robotics module is sort of designed as a miniature version of the course of similar courses we offer at the undergraduate level. Obviously, we can't go into as much detail, but the idea is to really give, a fire hose in terms of introduction to content and practical tasks, ending in a final challenge which they solve on their own. And again, you realize that this hands-on project-based approach is really important, and the outcomes are much more than just technical skills. Of course, they're learning programming, they're learning robotics. Many of them had never programmed before, but they're coming away with, and they are articulating, the high school students are articulating that they're coming away with skills in leadership and public thinking and critical thinking, teamwork, lateral thinking. And these are, of course, all things that are critical with respect to the kind of development we want to see in Africa. So, one of the participants said, that I believe this program will help to create a person who will in the long run ensure the development of his country and the world at large. So again, we're coming back to this idea of empowerment and the power of robotics education to do this. Ashesi has more recently began engaging in postgraduate education. So about 5 years ago, we started a master's in mechatronics engineering in collaboration with ETH Zurich. And it's a mechatronics engineering program. They take all the usual courses you would expect. Again, a strong focus on project-based learning. And so these videos are from the capstone applied systems engineering course, where the students had to design and build from scratch a robot that could cross a gap that was larger than the size of the robot at the start. So the robots had to figure out a mechanism by which they would then, cross the gap. And you have a number of different designs that students worked on. And again, this shows, just gives you the sort of reminder that the value of project-based learning is that it really helps students think creatively and think about how they can apply the skills that they're learning to problems related to Africa. The second master's program we started is the Master in Intelligence Computing Systems, which is more on the computer science side of things and integrates software engineering, AI, and cybersecurity. But even then, you try to introduce some courses try to incorporate robotics. So this was the Agile Software Engineering class where they were supposed to create a drone delivery system. So I think I should be wrapping up now because I lost connectivity. I think I lost a bit of time, but I'll just like to end by saying that through reiterating the idea that through project-based learning, we can have students really build capacity for the robotics ecosystem in Africa. That in combination with co-creating and in combination with taking advantage of external talent seems to be working well so far. Realities to confront in the West African context, we can't run away from certain things. The shortage of high-level talent, the fact that faculty may not have the luxury to give dedicated attention to robotics research, and of course, the usual things about funding, infrastructure, etc. But a lot can be achieved. So in summary, it's not just about technology. We want to train both the head and the heart so that students can think broadly about the world around them and have a sense of how they can contribute. So that's what makes me so excited about the revival of the African Robotics Network and the work that Kenechukwu has done in terms of the State of Robotics in Africa report.
Thank you so much, Dr. Ayorkor. That was a masterclass. Thank you so much. There are a lot of applause going up here, and they're very well deserved. Thank you so much for that awesome keynote. I will just share my screen in a minute, and it is such a great way to kick off this event. Thank you so much again, Dr. Ayorkor. So many great nuggets there that we, as we move into the panel, can expound on. And please feel free to, again, use the Q&A. If you have questions, I know there was at least one question, and I'd love to get more engagement on questions that we will then be surfacing to the speakers and the panelists.